Try to solve it yourself. When the inverse function of fx is gx, we have to find the inverse function of each function. So let's try to solve the first one. Find the inverse function of a times fx. The inverse function has a unique equation shown like this. When f's inverse function is gx, f gx is equal to x, and also g fx is also equal to x. We have to use this to find the inverse function of a times fx. Let's put the a times fx inverse into a large gx. We need to express the large gx into a small gx. What we know from this equation is that large g a fx is equal to x, and a times f large gx is equal to x. And because we can divide a on each side, f large gx is equal to x over a. Because g fx is equal to x, let's put in the g on each side. Then we will have this equation, and because g fx is equal to x, and if we change the x into the large gx, this equation will be shown like this. Large gx is equal to small g x over a. Because of that, the answer for the number 1 is a times fx inverse function is equal to g x over a. Now let's try to solve the next one. Equation 2. What is the inverse function of f(ax)? We use the same equation. When the inverse function of fx is gx, f gx is x, and g fx is x. Let's put the f(ax) inverse function into a large gx and solve it. Because large gx is inverse function of f(ax), large g f(ax) is equal to x, and f a times large gx is equal to x. Let's put in g fx is equal to x in here. Then we will have gf a times large gx is equal to gx. Because g fx is equal to x, let's substitute x into a times large gx. Then the insides will come out, and a times large gx is equal to gx. Therefore, large gx is equal to 1 over a times gx. So the inverse function of f(ax) is equal to 1 over a times gx. Therefore, inverse function of each 1 and 2 will be expressed like this.